On Monday, May 18th. An asteroid nobody knew existed just days earlier will pass terrifyingly close to Earth. 56,000 miles away, closer than the Moon. But what should unsettle you is not this asteroid. It is everything we still cannot see, the unseen. 91,000 kilometers. That's the final distance, just 56,700 miles, separating asteroid 2026 JH2 from Earth at its closest approach. Not a hypothetical, not a simulation. This Apollo-class near-Earth object will pass within a quarter of the Moon's distance, a gap that, in cosmic terms, barely registers. Estimated at 15 to 30 meters across, it's a rock the size of a blue whale or a city bus, traveling at nearly 20,000 miles per hour. The official discovery came only days before the flyby, after a faint, fast-moving point of light was finally picked out by survey telescopes. By then, the asteroid was already racing toward its encounter, too dim and too small to be seen until it was almost here. This is not unusual. Most objects of this size slip past undetected or are revealed with only days to spare. 2026 JH2 is not a fluke. It's a measurement, a hard number of how close and how late these cosmic visitors can appear. Detection begins with light. For an object like 2026 JH2, that light is almost nothing, a faint glimmer against the stars, scattered by a surface as dark as charcoal. Most survey telescopes are tuned for larger, brighter targets, and their sensitivity drops away for small, low albedo bodies. Even a 20-meter asteroid, if it reflects only a few % of the sunlight, remains invisible until it comes painfully close. The sky itself adds to the challenge. When an asteroid approaches from the direction of the sun, its path falls into the twilight blind spot, a region where glare overwhelms faint traces, and telescopes must turn away to protect their optics. There are gaps, too, at dawn and dusk, where the geometry of Earth and Sun creates daily windows of blindness. Fast motion brings a different problem. As a small object speeds across the sky, its image smears into a streak, spreading its light thin and slipping beneath the detection threshold. Survey coverage is not global. Most large telescopes scan the northern sky, leaving swathes of the southern hemisphere underwatched, especially in winter. These are not failures of vigilance. They are the physics of darkness, geometry, and speed, limits that define what can be seen and when. For asteroids like 2026 JH2, late discovery is the rule, not the exception. At 9:20 on a winter morning in 2013, the city of Chelyabinsk became the stage for a cosmic intrusion. A rock, just 17 to 20 meters wide, entered Earth's atmosphere at nearly 19 kilometers per second, silent at first, then suddenly brighter than the sun. The fireballs split the sky, caught in dozens of dashcam recordings and security feeds. Seconds later, a shockwave swept through the city. Windows shattered in a radius of 35 kilometers. Glass rained down in offices, schools, and apartments. More than 1,500 people were injured, nearly all by flying shards. The blast released energy equivalent to 400 to 500 kilotons of TNT, 20 times Hiroshima. Yet the object never touched the ground. It disintegrated high above, its fragments scattering across the frozen landscape. In a city of over 1 million, there were no deaths. But the scars, shattered facades, bandaged faces, the memory of a sun that rose twice, remained as proof that a rock the size of a city bus can turn a normal morning into a disaster. In the summer of 1908, a force unlike anything in recorded history swept across Siberia. Without warning, a body, estimated at 50 to 80 meters wide, entered the atmosphere at a steep angle and detonated high above the remote Tunguska River. In a single moment, energy equal to 10 million tons of TNT was released. The blast wave flattened over 2,000 square kilometers of taiga, snapping trees like matchsticks. and scorching the landscape in a radial pattern visible for decades. Yet, when scientists arrived years later, they found no crater, only a wilderness of leveled forest and a haunting silence. The object never touched the ground. Its energy, unleashed in the air, erased everything below. No city stood in its path, and the nearest witnesses were nomadic herders, left to describe a sky split by fire and a shock that circled the globe. Tunguska remains a warning written in the wilderness, a regional catastrophe delivered by a rock smaller than a football field, invisible until the moment of destruction. The search for hazardous asteroids is a numbers game, one measured in kilometers, meters, and the odds of being seen in time. Humanity has almost finished the census of the giants. More than 90% of near-Earth objects a kilometer or larger are catalogued, their orbits mapped, and their future encounters predicted decades ahead. For the next tier, the city killers, those around 140 meters across, the picture is less complete. Only about 40% have been found. Below that, in the realm of objects like 2026 JH2, the protective net thins to a handful of threads. Fewer than 5% of small, fast, faint bodies are discovered before they pass near or cross our path. The Rubin Observatory, now in final preparations, promises to double or triple our reach when it begins full operations. But for now, the gap is real. Most small asteroids will arrive unannounced, their presence revealed only by a sudden streak across the sky or, sometimes, by the damage left behind. NASA's Double Asteroid Redirection Test, or DART, struck its target in September 2022. It was a direct hit that nudged the orbit of Dimorphos, proving that a kinetic impactor can alter the path of a hazardous object. The science is real, but the mission required years of planning, a known target, and a dedicated spacecraft. There is no rapid response system, no standing fleet, no equivalent to a fire department waiting for the alarm. If a rock like 2026 JH2 had been on a collision course with only days of warning, humanity would have nothing ready to launch. The capability exists in theory, but the infrastructure to act on short notice does not. For now, safety is a matter of luck and orbital chance, not operational readiness. Tonight, the sky is quiet, but most asteroids like 2026 JH2 are found only days before arrival, if at all. Our safety is still a matter of luck, not readiness.